So let's start with an example grammar. So the example grammar we are going to start, and this is my Jupyter notebook. The example grammar I'm going to start is the natural number grammar. So it's the grammar that n generates z and n generates successor of n. So in this grammar, the non-terminal is the n. The terminals are going to be z with no argument or successor with one argument. Okay so far? So I need to and start symbol, which we don't care much about. I mean, this is something we won't use in Scala, but the start symbol is n. But we don't need that for now. Okay, so here's how I'm going to try and translate this into Scala. Okay, so I'm going to write something and I'm going to explain what it means. So let me keep it minimal. So this is how I'm going to write it in Scala, okay? And I'll explain what each of these things mean. Question? Yes, so dot means that it is a term that takes in one argument. So successor is a single argument function. You can think of it as a function, or we won't call it a function, we'll call it a symbol that has an argument inside it. If you think of it as a node in a tree, it has a single child to it. So which means that there is an inner term inside it. So any of the rules I write will have to respect that. So what are my rules? My rules are already here. So you see, in any rule, if I use successor, I'm going to always have a single argument inside it. Okay? All right. So this is how you would write this whole thing in Scala. So the idea is, for every non-terminal, you would declare it as something called, and I'm going to explain what this is, something called a sealed trait. Okay, you can also get away by calling it sealed abstract class. It's almost the same thing, and it also works, okay? But I'm going to use the term trait because it's just one word, whereas abstract class is 2 words. Okay, so this is called a sealed trait, and then you say the non-terminal n, right? So this is how I'm going to declare a non-terminal. Okay, and then for terminals, I don't declare them, but I introduce them via the rules. So here is a rule that says n derives z. So I'm going to say case class z, and z has no arguments to it, extends n. Okay, so you already know what a class is, but the question is, what is a case class? And I'll explain what a case class is in a second. So each of these things I'm going to explain, and then we'll bring this back together and see what this does for us. All right, and then you say n yields successor of n, and you say case class successor applied to a single argument n, which is a natural number, extends n. So this can be read as n derives z. This extends n is this part, which is this part, and this can be read as n derives successor of n. And this has to be n, sorry, not nat, n. Okay, so this is n derives successor of n, looks like this. This looks really funny. Let me explain what each of these things is, and then we can go from there. All right, let me start by defining what is a trait. What is a trait in Scala? Or it's another thing, the same name, I mean, it's a very similar concept to something called an abstract class. So a trait in Scala is an abstract class, which means that it is a class which, you know, exists but will never be defined. So remember, you can do the same thing in C++. You can have these classes that have this function called virtual 0 function. So you in C++, you can write something like this. You can say class hello, let's say, and then you can, inside the class, you can say virtual void, let's name the function foo. What did I just do? Oh, here it is. Virtual void foo int n equals 0. Have you ever seen this in C++? So you can actually say equals 0, or in more recent versions, I think you say something like equals delete or something. The idea here is a class where you declare a function, but you don't define it in the class. What you have to do is you have to inherit from this class. So let's say class hello implementation. And here extends, and you can say in C, this is the syntax, public hello. So in C++, you have to say this. This is how you extend from a class. And here you can say, instead of, you can say virtual void foo int n, and you can define it. You provide a definition. Okay, you can say printf n or something like that. So you provide a definition. So it turns out that hello is like an interface class or defines an API, but does not implement it. Whereas here, the implementation derives from the base class, but the functions that are missing, the functions for which you did not give an implementation, you better implement them. If you don't implement them, then C++ will complain. Okay? An abstract class or a trait is the same thing. So when I define something as a trait or an abstract class, so let me say abstract class foo. Okay? So that's just an abstract class. And I can even write something like this, def, function important n. So I have just defined abstract class foo, and that means that here is a prototype or a template foo or an abstract class foo in which there is a function called important function, but I haven't defined it, I've only declared it. Now if I try and instantiate this class, okay, let me give it an argument here. It's going to say foo is abstract, it cannot be instantiated. So you cannot instantiate these abstract classes. Okay, and instead of abstract class, for now, just take it to be the same thing. A trait is the same as an abstract class in Scala. Okay, and now if I wanted to instantiate it, I would say class foo implementation. Okay, and here I better define this function. I better have the same function, but I better define it, or else it's going to still be abstract. And here I have to say extends foo. Okay, so this is inheriting from foo. Okay, I'll answer your question in a second. Let me finish this. And let's say I'm just going to return n plus 1. So this is the implementation. Oh, if I define it as a trait, I shouldn't use the open brackets, close brackets. Question? No, Laurent says that you already answered this question. Okay. If I define it as a trait, one of the things I cannot do is put arguments to traits. So traits cannot have members like this. I cannot have members in traits. Traits have to be like this, without any members. Abstract class can have members. So in an abstract class, I can say I can do this in an abstract class. This we'll take this up later. We'll take this up later. So for the time being, I'm going to keep things as traits. So now I've done that. Instead of foo, I can say foo implementation of foo, and then I have that. Then I can say h dot val y equals h dot function important 10, something like that. I can call these functions. I can do all these things now. So this is a very simple form of inheritance. I haven't talked yet about inheritance, but you can now see how classes can inherit from each other, just like in C++. In Scala, you have this concept of an abstract class or a trait, same thing. These define an interface, but they don't necessarily implement that interface. You will implement them in a child or a derived class where you are going to implement all the things that you would promised you would implement. Okay, so far? So that's how you start with this. So when you look at this definition, so you're defining a class hierarchy here. You're defining something called N. Now, what is the sealed business? Okay, question. Oh, can I have vars or vals? It can have a var, so I can have, inside a trait, I can say var my mutable, something like that. I can have that. And you can say n plus my mutable. Okay, in fact, I can say my mutable equals my mutable plus 1. I can do all of that because this is being inherited from foo. Everything defined in foo is going to be part of foo impl as well. So my mutable is part of foo implementation as well. So I can do vars and all that. Okay. You can also do a val. I can also do a val, in which case this would be a bug. Right? This wouldn't compile because I would then be updating a val. But I can do a var. These are fine. Okay. All right. So this is the whole idea of defining a trait. So I define a trait called n. So I'm not going to be able to instantiate n directly. N is just this thing, this parent thing that exists, but I'm never going to be able to instantiate it. On the other hand, why do I call it sealed? So in a Jupyter notebook, I don't need to call it sealed, but in a real Scala program, you would call it sealed trait, because the convention is when you say sealed trait, or when you say something is sealed, like a class is sealed, which means that everything that inherits from that class has been defined in the same file. If you move to a different file and try to write a child or a derived class from that, you are not allowed to do it. Okay? It's just a software engineering thing where you can say, here is my base class, and everything that's going to derive from it is already here in one place. Don't look for it anywhere else in any other file or any other part of my big project. If you want to say that, you would write it as a sealed trait, and it allows Scala to do some optimizations already. So using that, we will just write it as a sealed trait, though it's going to be optional. I can just write it as a trait. Everything still works. In fact, I could, instead of a trait, I could write it as an abstract class. Everything still works. These are all the same things. Okay? But, in this class, I'm just going to use this because when I want you to learn not just the Jupyter Notebook Scala, which is not really Scala, which is just typing some commands and seeing what results they give. I want you to learn how to program in Scala a little bit more. So it's good that you're learning this. Question?
So Logan is asking if a sealed trait is like a private field in Java.
It's not a private field. It's more like a abstract base class. Okay. It is okay. There is one aspect of a private field that is part of sealed trait, which is that you can only access it from things in the same file. Like when you declare something private in C++, the meaning is you can only access it from the same class, right? But it has that same effect that you can only access it from inside that file where you're defining things. You're not allowed to define things elsewhere. So it tells Scala that it's kind of sealed up, or it's kind of closed up. Don't look for definitions or don't look for further things elsewhere. Everything is here. Okay, and that allows Scala to do some nice things under the hood. Okay, so this is the first thing, sealed trait n. Now, what is a class? We already saw a class. So if I had written things like this, that is a different thing. But why case class? So I'm going to talk about case classes next. So let me explain what this thing case class is. Okay, so let me give you an example of a class and an example of a case class. And you will see certain things are different for a case class and a class. Okay, so let's do a class in Scala. This is what we have done. 2 lectures ago, I showed you an example. Assignment 1, you're implementing the rational class. Okay, there is a dirty little secret that class is already implemented in your book. Hopefully you see that, but that's okay. I'm not going to have you search for it. If you've already seen it, you've already seen it, but it's there. Okay, it's there somewhere, or something very similar is there. Okay, but don't worry about it. So we define a class. So let's define a class like my class. Let's say it has a string. Let's say it has an integer. Okay. And let's say define a function foo. Okay. Let's define a function foo which just prints something like this. So this is good enough of a class for now. Okay, and then I can say val p equals new my class. The string hello, the number 10. You've seen this so far. Okay. Now, what happens if I define the same thing as a case class? So let me take this whole thing as it is and define it as a case class. Certain really cool things happen. What happens? So again, it doesn't seem like anything great, right? So, but let me do this. Val p equals my class. So first thing is, I don't need to write a new. When I define a class as a case class, I don't need to keep writing new. Okay? The new operator is not needed anymore. And how that works under the hood is actually really cool. I will explain that in a second, how Scala does it for you. Okay? But certain things are happening. So what is happening is, I don't need a new. I can just define a case class without the new operator. I can just say my class hello of 10. There is something else you might have noticed. When I define this class, when I define P in the old definition without the case class, right? So this is without case class. See what the terminal is printing for your class? So it says P of type my class is ammonite. 1 second, right? Ammonite $session command 12 helper $my class at 489.247 D5. So you know that some internals are being printed here. Some internal junk is being munched up, hashed up, and printed here. But look at this. This P is actually the case class, right? Scala is printing some nice cool things here. It's actually printing my class hello 10. So what is case class then? So a case class is the same as a class. But when you put the keywords case in front of it, there is some magic stuff that Scala already does for you that you don't have to do yourself. What are the magic stuff Scala does? So Scala does some very simple stuff, like it implements a two-string operator by default. So in this original class, where I defined it without the case, there is no two-string operator. But if I had written a two-string operator, def two-string, let's say my internal two-string operator, okay? So suppose I define my own two-string. Override. I'll tell you why you need an override. I can do it myself, okay? And then if I did this, if I defined a new class, my internal two-string operator hello 10. So what is happening here? So by default, anytime you define a class, Scala has a two-string function inside that class. Okay? You can override that two-string to have your pretty two-string. If you didn't override it, you will have the default two-string that Scala produces for you. Okay, but when you write a case class, Scala rewrites the toString and gives you a better toString method. Okay, that's not literally like the thing that we are using, but that's one of the things Scala is doing for you in a case class under the hood. But Scala does some more things for you. So for example, you can write something like this. So when you define a case class, you can start comparing case classes. So you can say val p1 is my class hello 10. Val p2 equals my class. So just to avoid confusion, I'm going to call it my case class. Okay, instead of my class, I'm going to call it my case class. Let me call it my case class. Okay, let me call this my case class. My case class hello 10. Okay, and then I can say val p3 is p1 the same as p2. So it says true. Val p4 is my case class world comma 10. Now I can say is p1 the same as p4? False. So when I define something as a case class, I get a comparison operator that's built in for free. Scala just does a trivial comparison operator. It literally says this class has members x and n. So let me just compare two instances of this class by comparing x and comparing n. And Scala does that for you internally. You don't have to do it yourself. But what happens if you didn't make it a case class? If you didn't make it a case class, let me do the same thing for something that's not a case class. Right? Let's call this Q1. Let's call this Q2. And by the way, remember you have to write a new now. Let's write the same thing. Okay? And now let's do Q1 equals Q2. And you get false. Why is that? Because if you didn't do case class and you just do comparison, Scala defaults to just comparing their reference values or the internal pointer values of these class. If they are different, Scala is going to say they are different. But if you declare it as a case class, what Scala does under the hood, it defines an inbuilt method. It overrides an inbuilt method called equals. Okay? And equality comparison will call the equals method if it exists. So in a case class, the equality operator is overridden for you, so you can compare case classes for equality. Question?
Shen is asking that when would it make more sense to make a non-case class?
When would it make more sense? If I don't like what Scala is doing under the hood. 90% of the time, I don't want it. Seriously, I want my own equality operator. I want control over. I don't want like a language coming under the hood and inserting stuff that I don't like. Okay, so a lot of times I will not be using case classes. Case classes are used for a very specific purpose, and I'll talk about that. But mostly they are used for a construct in Scala called case pattern matching. Okay, and I'll talk about that. But the important thing is, many a time I don't want it to be a case class because I want to define my own equals method. I don't want Scala to define equals. So let me give you an example, right? You could have taken your rational, remember I asked you to implement a rational number class in assignment 1. If you had declared it as a case class, you didn't need to declare the equals method, right? It would compare two rational numbers. But then it would say 2 by 4 is not the same as 1 by 2. Because the underlying equality operator that Scala implements for you is not the one that you want. You want a different one. You want to reduce it to the lowest terms and then compare, or do something like, take the numerator of one times the denominator of another, numerator of one times the denominator of the other, and then compare those for equality. Right? So you want your own implementation that does what you want it to do, not what Scala thinks you should be doing, or some kind of a default. Okay, so far? And So the last but not least, why don't you need a new? Okay, the reason you don't need a new is what Scala does, and I will leave you to read it. When you define something as a case class, Scala defines something called a companion object. And this companion object comes with something called a factory method. I'll explain companion objects at some other point where it makes sense. You can read it up, go online, look up the web and say Scala companion object. There are many people who have written tutorials on it. It's one of those cool things that Scala does for you. Okay, and when you write something as a case class, Scala will automatically generate a companion object for you and something called a factory method. So you can just construct the class by calling its name and giving it the arguments without putting a new in front of it. What is called is a factory method in a companion object which creates an instance of your class. Okay, so far? So I've told you what a case class is. So then how does this all help in our implementation? So I claim that this, when I say seal trait n, case class z, case class successor, I have implemented my grammar. So I can now write some terms. So I can say val 1 is going to be successor of z. So I can say val 2 is successor of z. I can say val 3 is successor of z. So I can write the terms in my grammar automatically as objects in Scala. And I can say is 1 equals 2. That's obviously false. I can say is the successor of 2. Oops, sorry. Is the successor of 2 the same as the successor of 3? No, is the same as 3. And that's true. So what I can do is I can instantiate my grammar inside Scala this way. And then I can do these things like I can write terms in Scala and I can compare those terms and so on. Question? Question? No? Okay. Okay? All right. So this is how you do it, right? So let me take a more complicated grammar and try to do it for a slightly more complicated grammar. So let's do this other grammar we were writing. So let me write that grammar down. So that grammar had non-terminals A and B. Those were the non-terminals. That grammar had terminals where X, I'm going to write everything in capitals because Scala, when you define classes and types in Scala, they have to be capital letters. Names of classes have to be capital letters. The only things that can start in small letters are the names of vals and vars inside your program. So in Scala convention, everything has to start with a capital letter. Okay, so I'm going to use capital letters instead of small letters, and then Z with 1 argument, and then W with 2 arguments. This is the grammar I wrote down earlier in the class. I'm just copying over. Okay, and then I had rules. My rules were A gives Z of A gives W of AB, A gives X, A gives Y, A gives Z of B, something like this. Okay? Is that good so far? Let's make it slightly simpler. Let's just leave it like this for now. Okay? Good. So let me just take these 4 rules. How do I write these rules? So non-terminals just become sealed traits. Okay? Yes. Oh, we had that. Thank you. Otherwise, B has no rule, does it? And then let's say A gives something like Z2. There's a technical reason I have to do things this way of B, something like that. Okay. So let's start with this. So we have seal trait A, seal trait B, all right? And then let me add Z2 here with a single symbol, with a single. Okay, so every non-terminal, make it into a sealed trait. So declare it as a sealed trait. And now every rule becomes like this. So you say this rule, the first rule, A gives Z of A, is expressed like this: case class Z with an argument A, okay, small a of type capital A, extends capital A. So this is how you would write the rule A gives Z of A. Okay, so let me also state something in a bit. So case class W, A of type A, B of type B, extends A. So this is A gives W of A comma B. Okay, then you say case class X with no arguments extends B. This is B gives X. Case class Y with no arguments extends B. B gives Y. Case class Z2 with an argument of type B extends. What should it extend? I am now encoding this last rule. A, the thing on the left hand side. Okay. Now you notice there is a limitation. When I said you can write these grammars in Scala, it turns out not every grammar can be written. There is a restriction here. You cannot have like rules like this where Z is a constructor symbol in this rule and Z is a constructor symbol in this rule. You have to change the names, otherwise you would have two definitions of the class Z, which are different. So you don't want to have that, so you have to have it like that. Okay, you have to give it a different name if Z is appearing in two rules. And the nice thing is, any of the grammar we care about, this restriction will be naturally satisfied, so I don't even have to mention this restriction. The only reason this has come up is I accidentally wrote an example where this restriction shows its face, but we will never ever encounter this in the grammars that we are interested in. So now you have defined all of these, and now you can write terms. So val term 1, so let's write the term we derived. So this was the term W of Z2 of Y, comma Y, something like this. So this is an example of a term that you can write in this grammar. Hold on. Oh, sorry. Whenever I write Y, I can't just write Y. I have to write Y with open brackets, close brackets to show that it has no arguments. Okay, which is somewhat problematic. Okay, so if you really wanted to be faithful, instead of calling this a case class, you would call it something called a case object, and I'll explain that in a second. Case object, and then you take away the open bracket, close bracket, and now you can write your definition like that. So now you can write your definition like without the Y bracket, and it works. Okay, now let me tell you what is the last concept, the concept of an object in Scala. Okay, so an object in Scala is a class for which only one instance of the class will exist. You cannot instantiate it. It is instantiated with just one instance of the object, and the name of that would be hello. As an example, let me define an object called hello, and then let me write a function. Okay, if I did that, and then I said hello, then I said val h equals new hello, I am not allowed to do it. Okay, I am not allowed to define an object of type hello. This is an object in Scala is different from a class. An object is a class of which exactly one instance exists, and that instance is already called hello. So I cannot define new hello, but since hello already exists, I can say hello.hello world. So this is like a way in which you can take an object and predefine just one instance of it, and that's called hello. This exists in C++ or in Java, and this would be called in C++, this would be called a static class. Okay, if you know this concept, it's called a static class in C++. And these are called objects, and by the way, objects will have no arguments whatsoever. You're not allowed to have arguments in an object. Question?
There's 3 questions.
Okay.
And so Colin is asking, is an object just a singleton class?
It's a singleton class in the sense that it's a class for which just one instance exists, and you don't get to create it. It's created the moment you declare it.
Okay. And then Michael is asking, is it the same as a static class in other languages?
Yes, an object, the question is an object the same as a static class? It's exactly the same as a static class in other languages. Like in C++, this would be the static class in Scala, it's called an object.
And Willem is asking a more open-ended question.
Mm-hmm.
Saying that these rules are very abstract and don't have meaning.
Yes.
Kind of lost as to why we would need this.
Yes, and that's exactly what's coming up next lecture. All right. So I'm going to talk about how are you going to define things using these rules, and how are you going to give the definition some life. By the way, my notes already have that, so you can actually look at my notes for some of that already. Question?
And then Keith is asking that what can't you have in objects?
What can't you have in objects? So you cannot have anything like, so you cannot have class parameters in objects. So you can't have x colon string y colon int. You cannot have that in an object. Why? Because remember, objects aren't meant for you to instantiate. Like there is no x for which you want to find the value and call a new operator. Remember, objects aren't meant to be used with new operators. So you cannot have like parameters to an object like this. Everything has to be defined. So if you do val x 10, that's allowed. If you do var y equals 15, that's allowed. You can do things like private var, that's allowed. I can't call it x, I have to call it x2. Okay, so the point here is, so today I wanted to show you 2 things. One is grammars define some structures, and you can actually take grammars and try and express them in Scala. Okay, what does this mean? Why do we need it? How do we work with these grammars? These are things I haven't talked to you about. So the notes that I have, and by the way, not everything in the notes is in the lecture, but you should be aware of everything in the notes. So I've posted a write-up called Inductively Defined Structures, Jupyter Notebook. So read through that notebook. In that notebook, I have defined other things like lists, trees, and some programming language concepts as well, which I'll come back to in the subsequent lectures. Okay, where I will show you how to work with these definitions, how to implement functions on these definitions, and so on. So